Good day, students. How are you doing? Today we continue our class on force and motion with the subtopic force, mass, and acceleration. Let's go through some nuggets. The greater the mass of an object, the smaller the acceleration it is given by a particular force. Mass is the property of an object that resists changes in its motion. To double the mass of an object by 2, the acceleration of the same object will be halved. That is, multiplying mass by 2, you reduce acceleration by half. Force is the action of one body on another body that causes its velocity to change. It is expressed as force, denoted with F, is equal to mass, denoted with M, multiplied by acceleration, denoted with A. Force is measured in newtons. Newtons is the force required to give a mass of 1 kilogram and acceleration of 1 meter per second squared. Now, let's go through some activity. What force is needed to give a ball of mass 0.1 kilogram and acceleration of 500 meter per second squared? You already know that force is equals to ma. With that, the mass is 0.1, then the acceleration is 500. What you just need to do is to shift the decimal point on the 500. This counts, yes. Just shift it behind by 1. That will give us 50.0 newtons. So let's check. That's correct. Now let's go for another question. An Airbus A380 aircraft has 4 jet engines, each capable of providing 320,000 newtons of thrust. The mass of the aircraft is 560,000 kilograms when loaded. What is the greatest acceleration that the aircraft can achieve? Here now, the mass of the aircraft is 560,000 kilograms. And the force on it is 320,000 newtons. So how do we then get the acceleration? Knowing fully well that force is equal to ma. Then the acceleration now will now be force over mass. With that, acceleration now equals to the force of 320,000 is only meant for one engine. So making 4 engines gives 4 times 320,000 divided by 560,000. And you know that acceleration is measured in what? Meter per second squared. That gives us acceleration 2.2 meters per second squared. So do we have that as an option? Yes, correct. That's good. Now let's move on. What force is needed to give a car of mass 600 kilogram and acceleration of 2.5 meter per second squared? So force is still the same in its approach, force. is equals to mass times acceleration. So we have 600 times 2.5. And that gives 600 times 5 over 2. 2 here 1, 2 here 300. And that gives us 1,500 newtons. Do we have it as part of the option? Yes. So we pick that. Correct. So another question. What is the acceleration produced by a force of 200 newtons acting on a person of mass 80 kilogram? So let's do the calculation here. F also will always be equal to ma. We are to look for acceleration, which is equal to force over mass. Our force is 200 newtons, while our mass is 80 kilograms. So this cancels this. 4 in 8, we have 2. 4 in 20, we have 5. And that acceleration gives what? 2.5 meters per second squared. We already have 2.5 meters per second squared. Let's see. Correct. Now, let's proceed. So, activities and past questions we are still dealing with. What is the meaning of the weight of an object? Can it be the density of the material from which it is made? No. Density is the mass per unit volume of a material. Can it be the pressure it exerts on the floor? No. Pressure is the force per unit area. The mass of the matter it contains? No. Mass of an object is unchanged, while the weight of an object changes on the surface of the earth. Weight now can be the force exerted on it by what? Gravity. That's correct. Yeah. Now, the force of gravity acting on an astronaut is an orbiting spacecraft is less than when she is on the Earth's surface. Compared with being on the Earth's surface, how do our mass and weight change when she goes into orbit? Mass in orbit decreases, weight in orbit unchanged? No. We always say that mass is always what? Constant. That means it is unchanged. How about weight in orbit? Can it decrease or increase? Let's see. Mass in orbit is unchanged, yes. Weight in orbit is unchanged. Weight will always change. Mass in orbit decreases, no. Mass is unchanged. Weight in orbit decreases, no, because of mass, which is always what? Unchanged. That is fixed. Then weight in orbit decreases because it has left the what? The space available for it on the Earth. So let's pick it and see. That's correct. So with this, we've come to the end of the class, but let's deal with the summary before we call it a day for today. Mass is the property of an object that resists changes in motion. Is that correct? Yes. But let's deal with other statements to confirm their validity. Mass is the property of an object that resists changes in its stationary state. No, the statement is false. Weight is the property of an object that allows changes in its motion. No, the statement is false. So mass is the property of an object that resists changes in its motion. Now, we've come to the end of today's class. Do well to subscribe to our website, www.edubbey.com, for more interactive books and class. Thank you so much for your time. You have a great day.